So this lesson is the introduction of a unit circle. Okay. A unit circle is called the unit circle because, well, before I do that, the unit circle is on an XY coordinate grid. Okay. So it's called the unit circle because the radius of this circle is equal to 1. Okay. So if it's equal to 1, then I know that this point here, what is the coordinate of this point? If this radius is 1? 1, 0, right? 1, comma 0. Okay. What is the radius, or if the radius is 1, what is the coordinate of this point here? Huh? 0, comma 1. If the radius is 1, and I go to this point, what is this point? What is the coordinate of that point? Negative 1, 0. And then if I go radius of 1, what is the coordinate of this point here? 0, comma negative 1, right? Simple and easy, right? Okay. So in degrees, in standard position, the degree measure of this angle here is 0 degrees, right? Let me just focus on that. Okay. That is 0 degrees. What is the degree measure of this guy in standard position? 90. The standard position of this angle here, 180. The standard position of this angle here, 270. And if I go back around and make a full circle, this would be 360, right? Okay. Oh, that's 270 down there. All right. Okay, cool. So now let's put it in radian measures. 0 degrees, you know it's 0, right? Okay, so going over the radian measure, this is 0 degrees. What is 90 degrees in terms of radians? Or what is, let's do the easier one. What is 180 in terms of radians? Pi. So if 180 is pi, half of it is pi over 2, right? If this is pi over 2, I have 2 pi over 2. This will be 3 pi over 2 then, right? Yeah. If I have pi over 2, which is 90, right? 180 is 2 pi over 2 or pi, right? And just keeping pi, just adding pi over 2 to pi, that would be 3 pi over 2. If I go full circle around, this would be, in radian measure, 360 would be 2 pi, right? Okay. Everybody good with that? Now we have these 3 radii in each quadrant. And these 3 radii is going to be based off of the 30, 60, 90 and the 45, 45, 90 triangles. Okay. So let's review those before we go ahead and we do this. Okay. So here I drew 2 sets, but let's just focus on the first one. Okay. In a 45, 45, 90, what is the ratio of the sides? It will be 1. Across the 45 is 1. Across the 45 is 1. Across the 90 is square root of 2. Right? And if you guys are not comfortable with this class, the unit circle will be difficult. Okay. So get comfortable with this. Okay. You guys aren't there yet. That's fine. But you guys got to get comfortable. Okay. In order for the unit circle to make sense. Across the 30, of a 30, 60, 90 is 1. Across the 60 of a 30, 60, 90 is square root of 3. Across the 90 would be 2. Okay. Questions on these side measures or the lengths of the sides? Okay, now you know how we started off by saying that this radius or this circle has a radius of 1, right? If I plopped this triangle here onto this the circle, if you guys can see you guys can't see the outline, but the radius of the circle would be this side, correct? Yeah. You guys can just envision or imagine that this triangle was plopped on and a reference angle would be here, right? So this angle here, class, is actually 30 degrees. Okay. Remember, 30 degrees in terms of radians is pi over 6. Okay. All right. So if this has a radius of 1, but my triangle here has a radius of 2, right? How do I make this a 1? It's not a trick question. What do I have to do to make this 2 equal to a 1? What operation? Divide by 2, right? I can divide by 2 to make this equal to 1, right? So since I divided this by 2, I'm going to divide everything else by 2. Okay? Divide this side by 2, divide this side by 2. Okay? So now I have my radius equal to 1, right? Now I have this side not equal to 1, but it's 1/2. And this side here is square root of 3 over 2. Understand? Yeah? Okay. Next part of this, again, you have to imagine I trace this triangle onto this side here. Okay, onto the unit circle, right? My next question to you, I'm going to put it side by side. What is the coordinate of this point right here? What is the coordinate of that point? Huh? 3 pi over 2, comma, 1/2, right? You guys see that from this triangle here? Yeah. If it has a radius of 1, then that means that I went 3 pi over 2 to the right, and I went up 1/2, correct? Yeah? You guys see that? Yeah? So this would be square root of 3 over 2 and 1/2, comma 1/2. Okay? No?
That would make this be if the what's it called, the little corner that was in, or it would be tangent, and it would be 3 square root of 3 over 4, right?
Oh, the tangent? Oh, the tangent of this would just be 1 over square root of 3 or square root of 3 over 3. Remember, it's opposite over adjacent or y over x. Yeah. So now it's a good transition. Can we get cosine of 30 and the sine of 30? What is the sine and cosine of 30 if we're using these numbers? Let's use these numbers. Okay. What is the sine of 30? 1/2, right? Because it's opposite over hypotenuse, correct? Or y over r, okay? Cosine of 30 is x over r, or adjacent over hypotenuse. So it's square root of 3 over 2, right? Okay. So now what I want to do with this is kind of compare it to the point. There's my coordinate right here. And here's sine and cosine of this angle, right? Of this 30-degree angle, right? What connections can I make? It's not a trick question. Here's the coordinate of this point that we got from here, right? This is the sine and cosine of 30 degrees. This coordinate represents 30 degrees in the unit circle. What connections can I make? They both have a denominator, but you can go further than that. It's not a trick question. What's the same thing? Be more specific. X is equal to cosine. Y is equal to sine, right? Yeah. So now in the unit circle class, that's why this is important. The coordinate of that unit circle is going to be cosine of whatever that angle is, theta, comma, the sine of whatever that is, theta, that angle is. Okay? So if I ask you, hey, what is the sine of 90 degrees? 1. Yeah. Hey, what is the cosine of 180 degrees? -1. Okay. Hey, what is the sine of 30 degrees? That's 1/2. Okay. That makes sense? Okay. Cool. I'm going to just finish this quadrant out and it will be done. Okay. Before I move to this next line here, I'm going to actually fill this out. This is a 45-degree angle. Okay, because it's right split down right in the middle, right, of this quadrant, which is 90 degrees. In radian measure, 45 degrees will equal pi over 4. This angle here is 60. This would be pi over 3. Okay. So now if the coordinates are cosine comma sine, what's the sine of 60? Or let's just look back here. Let's look back over here, but I'm going to flip this paper here like this. Okay. The sine of 60 degrees. Well, this is my angle then, right? Are you guys still comfortable with opposite and opposite, adjacent, and hypotenuse? Yeah. Opposite is rad 3. Square root of 3. And then my hypotenuse is 2. Rad 3 over 2, right? Cosine of 60 is adjacent, which is 1, over hypotenuse, which is 2. 1/2. Okay. So I know my coordinate for my 60-degree angle is 1/2 comma square root of 3 over 2. Okay. Here, 1/2 square root of 3 over 2. All right. Notice, I'm going to just point this out and we're going to talk about this relationship later. Notice that the 30-degree angle and the 60-degree angle, their sines and cosines, they just flip. Okay? The sine of 30 or the sine of 30 equals the cosine of 60, and the sine of the cosine of 30 became the sine of 60. Okay, there's a special relationship there that I'm just gonna leave as is for now. We'll get back to it in a little bit. Okay, probably next week sometime, but I just wanted to point that out. Okay, doing the same activity for the 45. Okay, so here's my 45, 45, 90 triangle with the ratios of the sides, 1, 1, square root of 2. In order for this side, right, my radius to be 1, I'm gonna have to divide this by square root of 2, correct? Yeah. This is divided by square root of 2. This is divided by square root of 2 then. Right? So square root of 2 over square root of 2, that's 1. 1 over square root of 2, rationalizing the denominator, is square root of 2 over 2. Okay, and this side would be square root of 2 over 2 as well. Cool? Okay? So my cosine, which is 1 over square root of 2, right? My sine, which is 1 over square root of 2, or I'm sorry, I pointed to the wrong side. So my cosine, which is adjacent over hypotenuse, 1 over square root of 2. My sine will be 1 over square root of 2, looking at the red numbers, right? So here is square root of 2 over square root of 2. Square root of 2 over square root of 2. Okay?
All right, so I'm some. I put that. Yeah. So like here are 2 over 2.
Oh, you know what? I wrote it wrong. Square root of 2 over 2. Square root of 2 over 2. I'm sorry. Okay. Now looking at the unit circle, if I have cosine and sine, right? What's tangent? There's something to think about. That's the lesson for today. We're going to fill this out later on.